everybody. You are welcome to Toidel online class. So today we want to start from where we stopped. So we are on the final revision on elementary maths 2. So we are going to concentrate on integration. We've actually talked about differentiation, so we are concentrating on integration now. So so I start. Before we consider examples in form of multiple choice question, let's just do a recap on integration. When we have a function y, which is called f of x, so under differentiation, we given a function, we have to find the derivative of that function. But integration is anti-differentiation. That is, in case of integration, you will not be given that derivative. You will have to find the function. That is, under integral, you will be given the derivative dy dx. It is equal to, let's say, xn, x raised by n. You will now be asked to find that function y. So in this case, now if divide this derivative, then the function y will now be, if you want to integrate this, will be x raised by n plus 1 all over n plus 1. That is plus arbitrary constants. Okay? So under integration, if you ask to integrate any function, you must take note of that. You must take note that if that is what you have, then this is really the derivative. That is, if you have xn dx, it should be xn plus 1 all over n plus 1 plus arbitrary constants. You see, there are two types of integration. The example I have here is called the indefinite integral. So if you have indefinite integral, once you integrate, it's a must to put arbitrary constants. Next is called arbitrary constant. It's a must, it's compulsory to put that constant. But if you have the second type of integration that has a bound in the sense that it has something like a all over b, this is called the lower bound, while this is called the upper bound. So this type of integration is called definite integral. So if you have definite integral, it is not compulsory to put arbitrary constant. It's not compulsory. If you like, you can put arbitrary constants. If you like, you don't even need to put arbitrary constant, because at the end of the day, the constant will cancel out. This is what I'm trying to say. When we have definite integral, definite integral, something like integral ab f of x dx. At the end of the day, we are going to have f of b minus f of a. This is what we are going to get. That is irrespective of this function now. By the time we integrate the function, you substitute for the value of the upper bound minus the value of this lower bound. By the time, for example, we are going to see all this. We are going to see this. So when we have integral sign that has bound lower, a is lower, then b is upper bound, you don't need to put arbitrary constant, because the arbitrary constant will actually cancel out. That's what we are trying to say. The arbitrary constant will cancel out. So now let's take example of integration. Let's take example. Let's start. For instance, example. Let's say example 1. If you integrate integral 3x squared dx, you can have something like this. If you have to integrate this, what do you do? So it's very simple. But as I've said earlier on, go and do revision. Just go and do revision on one of my videos, which is called the special functions. If you understand the functions, there won't be any problem. Integral 3x squared dx. This is what we have, integral 3x squared dx. So how do we integrate this? That's what we are about to do. How do we integrate this? Integral 3x squared dx. Then if you want to integrate this, you can bring out 3. So to have s squared dx. Then this same thing as 3. Then if you want to integrate s squared, that will be x. This is 2 plus 1. You add 1 to it. Then you use it to divide it. 2 plus 1. Whatever you have as the power is what you have as the denominator. Then plus arbitrary constant. Okay? At the end of the day, we are going to have 3s cubed 1 over 3. 3s cubed 1 over 3 plus arbitrary constant. 3 can cancel 3. At the end of the day, the final answer will not be s cubed plus arbitrary constant. So this example one that I gave now, is example under indefinite integral. So that arbitrary constant must be there. You have to include that arbitrary constant when you integrate. Okay? Because if it's multiple choice question, you can have this as one option, maybe option A. Option B, you can have something like s cubed without that arbitrary constant. If you pick this, you are wrong. Because this arbitrary constant is actually compulsory. So for us to be able to find the value of that C, we will need subsidiary conditions for us to be able to find that. But that's not the discussion for tonight. For today, we can talk about that some other time. So this example, this one example under integration. We can have another example. Say example 2, where we have integrate integral sine. You can say sine x dx. Okay. So please, there's some simple question. Of course, multiple choice question is very simple, but they are technical. So if you don't know, if you don't really understand it, we are going to fail. We are going to discuss them. So in this case now, if you differentiate sine, it is cos. If you differentiate cos, it's minus sine. Okay, it is minus sine. But in case of integration now, if you integrate cos, it's sine. But if you integrate sine, it's minus cos. So in this case now, integral sine x dx is going to give me minus cos x plus arbitrary constant. That's what you're going to get. Okay? This is what you're going to get. It's as simple as that. Then what if you have something of this nature? Say example 3. We can have something of this nature when we have integral. Then let's say we have something of this nature. S squared plus 3s cubed minus 4x all over x squared dx. You can be asked to integrate this. So what do you do here? Of course, if you have this, it depends on the approach I want to use. I might decide to divide through by this s squared. That is, I will say s power 4 divided by s squared plus 3s cubed divided by s squared minus 4x divided by x squared. Everything dx. Okay? So this reduces this to 2. So that here I'm going to have integral s squared plus this reduces this to x plus 3s minus 4. This reduces this to 4 all over x dx. So at this stage now, what do we do? Of course, when we have s squared, you know what to do. And of course, integration is linear. So if I integrate this, I'm going to get s 2 plus 1, that's 3. S squared 2 minus 4. In this case now, if you bring out 4, you have integral 1 over x dx. Okay? When we differentiate in x under exponential, we check example 7 or 8 in the former video, where we say y is equal to in x. The derivative is normal, the y dx is taken as 1 over x. Now that we now have the derivative to 1 over x, the function will be in x. So if you have like this one now, this one will now be, this will be s cubed all over 3 plus 3s squared all over 2 minus 4. Integral 1 over x. Integral 1 over x is going to give us in x plus arbitrary constant. We must add that arbitrary constant to it. Failure to do that will not enable us to solve the problem. So it's a must to put arbitrary constant. Okay? That is that about that. Then let's take another question. We can have question like integral 3x plus 5 dx. So how do we integrate that? We have question in that form. So what do we do? How do we integrate? How do we get solution to that type of problem? Of course, if you have this type of problem, then the first thing, since it is multiple choice question, let's first use the normal method. Then I'll now tell you the shortcuts. I'm not to get the question. I'll have to get the answer first. Tell us the shortcut. So in this case now, we have integral 3x plus 5 all cubed dx. We say let u is equal to 3x plus 5. So that du dx is equal to 3. Then we make this, if you cross multiply here, dx will not be equal to what? Du all over 3. That's what you do. Okay? If you do it that way, then in this case, we now go back to the equation. We have represented 3x plus 5 as u. We now have u cubed du all over 3. No, this is dx. But what is dx? When we represent u as the core, what you have in this bracket, this is what you are going to get. So I can bring out 1 over 3 outside, so that I have integral u cubed du. So this is as 1 over 3. If I integrate u cubed, that's u 3 plus 1. That will be u quart 1 over 4 plus arbitrary constant. At the end of the day, I'm going to get u raised to power 4 1 over 3 times 4 12 plus arbitrary constant. What is u? U is same thing as 3x plus 5. U is same thing as 3x plus 5. So finally, the final answer will be 3x plus 5 raised to power 4 1 over 12 plus arbitrary constant. That is what we are going to get. That is what we are going to get. So that's what we are going to get. So if you do that correctly, that is what we are going to get. So let's take note. That's what we are going to get. So all the examples that we have considered from example 1 to that the last example, they are still example under definite integral. They are example under definite integral. So I want us to consider example under indefinite integral. Under indefinite integral. So let's consider example under definite integral. That is, if we have the bound. So what do we do? Let's see example 5. Let's see another example. Example 5. From example 1 to example 4, at the end of the day, we normally add c, which is arbitrary constant. But what if we are given definite integral? Definite integral in the sense that it has both lower and upper bound. Let's say, for example, if you have integral from 0 to 1 dx, okay, something of this nature. So what do we do here? Or I can say integral 0 to 1 x dx. That is, I will have integral 0 to 1 x dx. So if I integrate x, x is x raised to power 1. I'm going to have x raised to power 1 plus 1, 1 over 1 plus 1, plus arbitrary constant. I want to show us the reason why we don't need to put arbitrary constant. If you have definite integral, 0 is the lower bound, 1 is the upper bound. Then here I'm going to have x squared 1 over 2 plus arbitrary constant. What we are going to do is that you put the lower here, then the upper here. Okay? Now substitute wherever you see x here, you substitute for 1 minus the lower. That is, I'm going to have 1 squared over 2 plus c. That's one bracket minus when x equal to 0 is 0 squared over 2 plus c. At the end of the day, we realize that we have half plus c. Minus will control everything in this bracket. 0, this is 0. This is minus 0 minus c. You realize that c will cancel out. C minus c will cancel out. At the end of the day, the answer is half. So if you are given definite integral, you don't need to put arbitrary constant because it's going to cancel out as we have seen it on the board. So it's going to cancel out. So you don't need to bother yourself. So let's see another example. Let's see another example under definite integral. Integrate. Let's integrate. If you have to integrate, here we have integrate x squared plus x minus 1 dx. Then ranging from minus 2 to minus 1. These are the bounds. Look at. So since we have lower and upper bound, you don't need to put arbitrary constants. Because at the end of the day, c will cancel c. So you don't need to put arbitrary constants. What we're going to do is just say minus 2 minus 1. X squared plus x minus 1 dx. And if you integrate x squared, that will be x 2 plus 1. We're going to have x cubed 1 over 3. Plus, if you integrate x is 1. 1 plus 1 is 2. We have x squared 1 over 2. Minus, if you integrate a constant, we are going to get, like where we have 1. So if you integrate 1, we are going to get x. Because we are integrating with respect to x. This will be x. Then from minus 2 to minus 1. Okay? We don't need to put arbitrary constants. Why? Because the arbitrary constant will cancel out. By the time we substitute the value. What are we going to do here? You substitute When x equal to minus 1, then minus 1 x equal to minus 2. Minus 1 cube will be minus 1 over 3. This will be plus 1 over 2. Minus minus, that's plus 1. That's what we are going to get here. You substitute minus, when it is minus 2, we have minus 2. It will be minus 8. Minus 8 over 3. Plus 2. That's what we're going to do. So we can actually try and find the LCM. Here, the LCM is 6. Here will be minus 2 plus 3 plus 1. Into brackets, that's minus. Here is also 6. The LCM is also 6 here. Okay? 3 here is 2. That's minus 16. Plus 2 here, 3. Plus 12. Plus 1. No, yes, there should be 6. Yes, 1. That's 6 times 2, 12. Okay? So at the end of the day, we're going to get 6 plus 3, that's 9. 9 minus 2. We're going to get 7 over 6 minus, this is 24. 24, that's 8. That will be minus 8. Minus is close. So that will be 8 over 6. At the end of the day, this is minus 8, right? Yeah, that is minus 8. That will be minus 16. So here we have 24. 24 minus, that's minus 8. At the end of the day, let's say 6. I have 7 minus 8. So that's minus 1 over 6. And that will be the answer. So minus 1 over 6 will be the answer. Okay? That's the answer that we're going to get. So when we have definite integral, you don't need to put arbitrary constant. So please, let's take note of that. We don't need to put arbitrary constant under definite integral. Okay? Then there's what we call integration by parts. We can have integration by parts. Let's see this example 7. I'm going to use this example 7 to explain integration by parts. Here we have integrate x e minus x dx. So when we have integral that consists of two different functions, this polynomial function x and this exponential function, most often time we use integration by parts, and that is one formula. Okay, we use integration by parts, and integration by parts simply means if you have v du, the same thing as uv minus integral u dv. That's what you are going to get. Okay, that is what you have here. You call one v, the whole of this one will be du. So if we do that, we can go ahead when we say x is equal to v, we can find the v. We're going to get the value for the v. Okay, so this is what we are trying to say. Any question you are given, write it in this one, so that you realize that v is equal to x. If v is equal to x, the v is equal to dx. Then at the same time, du is equal to e minus x dx integral. When we integrate u, we have du get u. If we integrate this, the derivative of this is minus 1. So we are going to get minus e minus x. That's what we are going to get. Okay, we are going to get minus e minus x. So what the question now, what we are given can now be expressed as integral x e minus x dx will now be u times v. What is u? U is minus e minus x. V is x. So I'm going to get minus x e minus x. Okay, minus integral. This is u. This is u minus e minus x. Okay, u. Then what is dx? Dx is dv. Dv is dx. Okay, from there we are going to have minus x e minus x. Minus times minus will be plus. If I integrate this, I'm going to get minus. So I'm going to get minus e minus x. That's what I'm going to get. Minus e minus x, then plus arbitrary constant. And if you like, you can bring out e minus x. You can bring it outside. So that at the end of the day, we have minus x minus 1 plus arbitrary constant, which will be our final answer. Or we might try to bring out that minus here. So that here I'm going to have x plus 1. That's what you're going to get. So under integration by parts, that is how to approach the problem under integration by parts. That's how to approach the problem. Then we can also have integration by partial fraction. Just that under integration by partial fraction, it may be a bit difficult. When we have it, it might be a bit difficult. We got to solve that using under multiplication longer. So we can have question like that. Then you can be asked to give, they may say the following are example of definite integral. I want to assume that you know the meaning of definite integral now. So that shouldn't be a problem. That should not be a problem for us again. Okay, that should not be a problem since we know definite integral. And we also have question under applications of differentiation and integration. So it's possible to have question under application of differentiation and integration. For instance, we can have this type of question where we have a particle is projected in a straight line from a point 0 with an initial velocity of 12 meters per second. So its acceleration Ts later is given by 3t squared plus 2t. So the question answers we should calculate its velocity after 2 seconds. We should calculate the velocity after 2 seconds. Of course, we are given the acceleration. Integration is the reverse of differentiation. Here now we are given the acceleration. So if we are given the acceleration, what do? We can actually integrate. We can integrate the acceleration in order to get the velocity. From the question, we are given the acceleration, which is written as dv dt, is the rate of change of time. It's the rate of change of velocity with time. That is acceleration. So the acceleration is given in terms of t as 3t squared plus 2t. So how do we get the velocity? Of course, we get the velocity. If we cross multiply, I'm going to get dv. So we got to 3t squared plus 2t into bracket dt. Okay? So I will introduce integral sign. If I integrate dv, I'm going to get then this. If I integrate this, I'm going to get 1 over 3 plus 2t squared 1 over 2 plus arbitrary constants. This will cancel this, this will cancel this. At the end of the day, v will be equal to c cubed plus t squared plus c. That is what our v will be. But we cannot get the value of v directly until we know the arbitrary constant. So how do we get the arbitrary constant? That is what we should be thinking about. How do we get the arbitrary constant now? How do we get the arbitrary constant? Of course, we are given the velocity. We are given the velocity to be 12 meters per second squared. And time, when you say it's initial velocity, at initial velocity, time is 0. So I would say we know v to be equal to 12 meters per second squared and t to be equal to 0. T is equal to 0. Since t is equal to 0, we are trying to find the value. We want to find the value of the arbitrary constant c. So if I substitute q plus 0 plus c, therefore c is equal to 12. So the velocity will not be equal to t cubed plus t squared plus 12. That will be the velocity that we are asked to find. So under integration, we can actually have short question. But just let us note that under integration, we are given the derivative. We are asked to find the function. That is the reverse of anti-differentiation. Under integration, what we are doing is that we are given the function and the derivative. We are asked to find the function. So I want us to just go through all this. Let's just be at alert. Then not only that, please go and check my video on special functions. Because if you don't know everything we talk about in differentiation and integration is functions. If you know trig function, then you can do an example. You'll be able to integrate or differentiate. If you know exponential function, we have so many functions. We have polynomial function. where we have 2x cubed plus 4x squared plus 3. If we have trig function, that's why we talk about sin x, cos x, cosec x. These are trig function. Okay? These are polynomial function, these are trig function. We can have exponential function where we have e raised to power 2x. We can have e raised to power in x. We can have e raised to power sin x. These are exponential functions. Okay? Polynomial function, trigonometric function, exponential function. We can have logarithmic function, logarithm function, when we have log e raised to power sin x. Okay? This same thing as in x, in sin x. This is natural logarithm. But we can also have something like log, this will be here, it will be here, and say 2x. So this one also has its own expression. Okay? We can have hyperbola function. We have so many types of function. So our inability to discover those functions will actually affect our results. So let me just stop here and give you time to go to reflect and go over what we have discussed. Thank you.